Hey, hello. Welcome everyone to this part 3 of CARMA, Critical Appraisal of Research Methods and Analysis. So from the last two parts, where we left off, we spoke about the use of science when doing science, and from here on, we're going to move to more elaborate. We're going to elaborate a bit or talk about what do we use data for and the situations where we need to use data. Because we, of course, use data for many other things than science. And for most people, science is the least relevant domain to use data in to begin with. But we spoke about p-hacking. We spoke about what happens when you're doing hypothesizing after the results are known, and perhaps a bit about so we call it survivorship bias. If only those results that are sexy and surprising, if those things get published and the other things don't. There's an analogy to that's been actually used in the world, so it's called the boxing scam, but I can explain it as follows. So imagine that so it was originally in the context of boxing betting, but let's think about the context of stocks. So you get a letter to your home that says that, hey, we're this firm and we have developed amazing AI-based stock market analytics. And just to prove our case, we're not asking for anything. We just want you to know that we're predicting that this stock will go up during the following week. You say, okay, sure, whatever. And then you forget about it, but then next week you get another letter. The letter says that, hey, remember us, we said that the stock would go up, and it actually did go up. And here's our prediction for next week. And you think of that's strange, and then you go and check, and the stock actually had gone up, and they had told the truth. And you're like, oh, okay, sure. And then the next week, they again send you a letter saying that, oh, hey, did you know this, that actually our prediction was correct once again. And again, and every week for 7 weeks, you get this same prediction. You get a prediction, and the prediction a week later turns out to be true. And you could carry on this for longer if you would be more skeptical. But in this case, you think that, oh, actually, getting 7 times right in a row, if the actual probability is just 50%, whether a stock would go up or down, if they were just guessing, the likelihood that they would actually get the guess right 7 times in a row for an 50-50 chance, if they were just guessing, the likelihood for that would be just less than 1%. So they must be onto something. And then, as it happens in their last letter, they're asking you to invest. And you're like, hey, okay, so sure, this sounds a bit risky, but they got it correct 7 times, or maybe for a long time, and then got it correct 10 times, which is like already a very, very, very improbable thing to get right. If it's just a conflict probability. And then you send them your money, and you never see your money again. And that's weird, you think. I guess I was ripped off after all. And then you talk to your neighbor, and your neighbor says that, Yeah, I actually got the same kinds of letters, but after the third letter, they got it wrong, and the letters stopped coming. So what's happened? And this is survivorship bias. So it's sort of the same situation as with publication bias or many other walks in life, where you don't see the silent evidence, as Nassim Nicholas Taleb calls it, but you only see a partial view of the world. So imagine that you're an entrepreneurial guy who wants to run a scheme for easy money. What you do is you take 12,800 addresses, and you post a letter to those addresses. And half of those addresses, for 6,400 households, you send a letter saying this stock will go up. And for half of them, you will send a letter saying the stock will go down. And the stock will either go up or it will go down. So next week, you will only take those 6,400 households for which you were correct in your prediction. And you again divide your sample to half. And so for half of the sample, you send a letter saying this stock will go up, and for the other half, you will send a message saying, a letter saying that it will go down. So now you have for 3,200 households in both. Then you continue this, and you always send the next letter to those households who got the letter that turned out to be right. And you end up with a situation where you actually make a very long streak of correct bets, which is completely random, and you were only guessing. But if you only were in the because you end up with 100 households who get it right 7 times in a row. So if you were one of those households and you didn't know about the rest of the scheme, then you would obviously have a very different picture of how the results came to be. And so here's a comical like about this. So there's this guy who says, who wonders why everyone is opposed to P hacking, because it's brilliant and you can control anything, and makes you a wizard, and just as long as you can pick the right day.